Welcome back to Stewart Science. Today we're talking about electrons. Specifically, what are they? What's their charge? How do you find the overall charge? How do you find the valence electrons in an atom? And then how do you figure out if an atom has charge or not? So first of all, just very basically, an electron is a negatively charged part of an atom that exists outside the nucleus and doesn't have any mass. Now, because it's on the outside of the nucleus, it's pretty easy to give and take away electrons on an atom. So when we look at bonding, the electrons are what does the bonding. Or when we look at reactions, the electrons are what's eventually causing the reactions. Or when we look at charge even, like how atoms get positively or negatively charged, it's because they've gained or lost electrons. So electrons kind of do a lot for the atom, even though they don't have any mass and don't change the element. They're what is involved in giving an atom its chemical properties. And so the first question to ask is, how many electrons would each atom have? Which is a very easy answer, because since electrons are negative and protons are positive, if the atom doesn't have an overall charge, it has the same number of protons that it has electrons. So let's say I said, what is the total number of electrons for fluorine? You find fluorine on the periodic table, it says right here, and whatever its atomic number is, which is 9, that's how many electrons it has. So fluorine has 9. If there's no overall charge, its atomic number is the same as the number of electrons that it has, because it has to have the same positive and negatives. So if I asked you, how many total electrons does magnesium have? 12 is your answer. Or how many total electrons does osmium have? 76 is your answer. Easy peasy, lemon squeezy. Now the valence electrons are a little harder question. A valence electron is an outer electron, and electrons live in energy levels, which we usually draw as rings. So we call these Bohr models because chemistry is boring. Get it? Boring. It's a guy's name. Niels Bohr came up with this. He said that electrons exist in energy layers around the nucleus. So take my word for this. There are 2 electrons that fit in the first ring, so that would be a drawing for helium because it has 2. And then there are up to, oh, what a horrible circle, up to 8 in the second ring. So 1, there's 3 total that we've drawn. That would be lithium, 3. There's beryllium. Boron is 5. There's carbon. Keep going here. So there's 8 more that fit in the second ring. So right now, if I look at this, this would be a Bohr model for neon, because there's 10 total electrons drawn, and neon has 10 electrons. And if I ask the question, how many valence electrons does neon have? Well, in this outer ring, there are 8 electrons. So neon has 8 valence electrons because there are 8 electrons in the outer ring. I could keep going here. So the order goes 2 in the first, then 8 in the second, then 8 more in the third. So this would be sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. And then there are 18 and 18 again. Don't worry about that. 2, 8, 8. That's what we care about. 2 in the first ring, then 8 in the second, then 8 in the third. Now, if this is all really confusing to you, there's a really easy shortcut for this. And that's, look at the Roman numeral above each column. Now, the periodic table on my video here doesn't have it, but most periodic tables have a Roman numeral I here, and then I, and then I, and then I, V, and then V, and then VI, and then VII, and then VIII. I realized it looked like I was focusing really hard. It's really small on my iPad here. But essentially what you end up getting is the first column has 1 in its outer ring. The second column has 2 in its outer ring. Then you skip all of these transition metals because I'm not going to teach those to you. Then the third Roman numeral column has 3, and then 4, 5, 6, 7, and ultimately 8. So look at the Roman numeral as the answer to that question. How many valence electrons does it have? Look at the Roman numeral above each column. Shortcut. All right, last question you might see from me is all about the charge if I give you the number of protons and the number of electrons. And as we've already mentioned before, protons are positive, electrons are negative. So the charge is going to be the overall balance or difference between those two things, the positives and the negatives. So for example, if I had 16 positives and 16 negatives, 16 protons and 16 electrons, my overall charge would be 0 or neutral because we have an equal number of protons and electrons. But if I had more electrons, more negatives, for example, 38 positives, 38 negatives, and 35 positives, this would be an overall negative charge because there are more negative charged particles. But we also need a number here too because it can be -1 or -2 or -3. This one has 3 more negatives than it has positives, so the charge would be a -3. And last but not least, you could also have more positives than negatives. So this example here, you have 19 positives and 18 negatives. 19 protons, 18 electrons. That means there's 1 more positive charge, so you would call this a +1. As always, this is Mr. Stewart. Keep learning, no matter what.